Alright, so I've had a Roomba lying around for a long time, and I didn't use it for a long time, and the battery wore out and got to really low voltage, and the Roomba refused to charge it. So the other day I bought this little circuit board here on Amazon for about $9.50. This circuit board, I put it inside an Altoids tin case. What it does is it's called a step-down DC to DC converter. So what it does is you can give it an input voltage and you can choose what voltage it should output. But the nice part about this one is it also allows you to choose what current you want to output. So for anybody who doesn't know, current and voltage is linked, and when you change one, it changes the other. So this guy, I told it to do a consistent 0.35 amps. So over here on the left, there's a LED that's going to turn on. That's the input voltage. On the right, when that lights up, it's showing the output voltage. So 22.6 input voltage, 16.3 output voltage, and then when it goes back over, it'll show the amps. So it's doing 0.35 amps. So the cool part about this is that I told it to keep it at a consistent 0.35 amps that it's outputting, and it will modify the voltage that it needs to keep that relationship intact to output a specific amount of amperage to the battery. So I've got a simple 5.5 by 2.1 DC plug here. It just so happens that the input, this is a factory Roomba plug, and this actually outputs, I believe it's 22.5 amps. Actually, we can just see on the input, yeah, 22.6. So it says 22.5 on it. I plugged it in, and then the voltage is being changed over to this battery. This battery is a 14.4 volt battery. It's I believe it's a 3.5 amp hour battery. I looked online and they said if you want to charge a nickel cadmium battery manually, that you could take the amp hours and divide it by 10 and then charge it with that many amps for 10 hours, and that should safely charge it, even with the voltage varying, because apparently that's not so important with a cadmium battery. Is like a lithium ion battery. It's very important to have a specific voltage and then switch over to a specific current. So right now I've got it in constant current mode, and this is charging the battery at 0.35 amps. So it's going to vary the voltage and make sure that this battery is properly charged. Over here I've got a second Roomba battery that I've been playing with. So I believe this has a temperature sensor or something on here. So under here there are two connectors, the positives over here, the negatives over here. So I've got these alligator clips with some magnets on top of them just to hold it down to keep it connected to the battery. So I can actually check the resistance of this. So it just stopped charging because it's kind of fiddly. So this was at 12 kiloohms when I first started. Now it's down to 10 kiloohms. So I believe that's kind of showing a representation of the temperature or something going on inside of the battery. I'm not certain on that one, but I did test this, and this battery bank here, this is a bunch of batteries in series, I believe, had like a 1.2 volts, so which is extremely low for having so many batteries in series. So they were pretty much dead. So I'm going to pull this off and you guys can kind of see what's going on. This is the negative terminal, and then that's mirrored on the other side. So I can use that magnet to keep those in place and charging. So one thing they did mention is that you want to make sure that the battery doesn't get too hot. So I've got this sitting on the floor here on some tile. The tile's about 24 degrees Celsius. Once the light turns off, come on, there we go. The battery is at about 24, 25 or so. So it's about 25 at most, but about 24. So it's really not much higher, if any higher, than the surrounding air and ground. So I'm going to keep this going, and in theory it should take 10 hours for it to hopefully rescue this battery that was completely dead. It was so dead that the Roomba wouldn't even charge it. So we'll see. I've never charged a battery like this, and so I was just looking around online about how to rescue a battery like this, and I'll go ahead and edit it here and get back to you guys in about 10 hours. We'll see how this worked out. Alright, so I wanted to show you guys the state of the other battery, which they were pretty much mirrored. So if I switch over to the voltage here, we can test the voltage of these batteries. And this is a whole series of batteries. It comes out to 1.6 volts. So this is a bunch of batteries, 12 of them. I'm not sure if they're all in series, but either way, it should be more than one cell's worth, unless they're all in parallel, which I really doubt, especially because this says, 14.4 volts. Right here, I think, is a temperature sensor. So if I measure this, you don't really get much of a voltage out of it. Yeah, not much of a voltage, but if you measure the resistance, you get about 11.2 kilovolts. So I believe that this second set of connectors here is probably for a thermometer or something that's built into this. So I just kind of wanted to show you guys the previous status of this battery, which has been charging for a few hours now. So you can still see that it's going, cycling through the volts, keeping itself at 0.35 amps. And just for reference, the temperature doesn't seem to have gone up really at anything. It's still at ambient temperature at about 24 or 25 degrees Celsius. Alright, so the charger seems to have dropped down to about 0.27 amps. So I had it set at 0.35 amps, and it switched off of constant current mode and switched over to constant voltage, and the amperage has dropped down. So I think that means that either the circuit has detected that it should automatically do this, or maybe there's something actually wrong with this battery more than being completely discharged. So I'm going to go ahead and take this all apart, and I'm going to put it into the Roomba and plug the Roomba directly into its adapter over here and let that actually charge the Roomba, the battery here, rather than this circuit. So I think it'd be much safer to have the Roomba fully charge this than this kind of system I've set up here, especially because I don't completely understand this technology. Okay, so before this would blink very rapidly, the yellow amber indicator light on here when it was attempting to charge, which meant that something was wrong with the battery or it couldn't detect it. So I've got this back on the charging station with the battery inside of it, and it's slowly blinking amber, which means that it's charging and it successfully detected the battery. So this seems to be a success so far. I'm not sure about the quality of the battery. I haven't used this Roomba in a few years, so we'll see how well it manages to clean up the house. Thanks for watching, and please remember to like and subscribe.